A silent skull can rewrite our entire history. This is the profound challenge waiting within ancient bone and stone. We are embarking on a journey to explore 20 ancient skulls and skeletons that stand as direct, physical challenges to everything we think we know about human biology and evolution. By the end, you will see the human story not as a straight line, but as a mysterious tapestry woven with lost threads and forgotten patterns. What secrets do elongated craniums hold that defy simple explanation? How could different kinds of people have shared the world so recently? We will uncover relics that question the very definition of humanity. What does it truly mean to be human when our past is this wonderfully strange? The Paracas Desert holds more than just sand and stone. It cradles a mystery that begins not with a whisper, but with a silent, impossible shape. In 1928, archaeologist Giulio Tello made a discovery that would ripple through decades of study. He uncovered a vast burial ground containing hundreds of individuals, but these were not like any others found in the region. Their skulls were dramatically, unnaturally elongated, stretching back from the forehead in a smooth, parabolic curve. At first glance, one might think of cranial deformation, a practice known in many ancient cultures where boards or cloth bindings are applied to an infant's soft skull to gradually reshape it over years. This was a cultural practice, a marker of status or beauty, but the Paracas skulls presented something that stopped that simple explanation in its tracks. For one, the sheer cranial volume of some specimens defies logic. While a typical modern human skull holds around 1,400 cubic centimeters of space, the largest Paracas skulls measure closer to 1,750, a staggering 25% increase. Head binding can change the shape of a skull, but it cannot create more brain matter. It cannot increase the internal capacity of the bone vault itself. Then came the most baffling anatomical detail. In a normal human skull, the parietal bones at the top of the head are separated by a zigzagging seam called the sagittal suture. This is a fundamental biological feature. In many of the Paracas skulls, this suture is simply absent. The top of the cranium is a single, seamless piece of bone. This is not a result of binding. It is a genetic, developmental anomaly that should not exist within our known understanding of human biology. So what are we looking at? The theory of deliberate deformation hits a wall of solid bone. This introduces our first profound challenge to the narrative. We are faced with a collection of individuals who physically walked the coast of Peru over 2,000 years ago, yet whose very skeletal structure suggests a different blueprint. Were they the result of an isolated genetic lineage, a people whose biology diverged in ancient times? Later, controversial genetic testing on hair samples from the skulls would claim to find mitochondrial DNA markers unknown in any human, primate, or animal database, a claim that remains fiercely debated. Whether that specific finding holds up or not, the physical evidence alone is enough to unsettle our assumptions. The Paracas skulls stand as a silent, stone-cold question mark. They ask us to expand our definition of what human variation looked like in the deep past, pushing us from the dry coasts of South America toward our next discovery, one that emerges from a deep, dark cave on a remote island. While the Paracas skulls challenge the shape of humanity, another discovery questions the very size of our potential. The year was 1913 near the small town of Boskop in South Africa. Workers unearthed a collection of ancient bone fragments that seemed unremarkable at first, but when scientists carefully pieced them together, they were not looking at a typical human skull. They were looking at a vessel. The reconstructed cranium was startlingly large, with a smooth, rounded dome that swept back in a gentle curve. measurements placed its internal volume at around 1,900 cubic centimeters. To put that in perspective, the average modern human brain fits within a space of about 1,350 to 1,450 cubic centimeters. The individual known as Boskop man, who lived during the late Stone Age, potentially had a brain more than 30% larger than ours. This was not a single freak anomaly. Other similarly large skull fragments were found in the region, hinting at the possibility of an entire population with this extraordinary trait. What does such a brain capacity imply? Neurologists point out that brain size alone is not a perfect measure of intelligence, but such a significant deviation is impossible to ignore. The neural architecture required to fill that space suggests cognitive potential far beyond the baseline of its time, and perhaps even of our own. The implications are profound. For decades, a common simplified view of human evolution portrayed a steady, upward march from smaller-brained ancestors to our large-brained modern selves. The Boskop discovery shatters that linear narrative. Here was a group of people, contemporaries of our own ancestors, who may have possessed a different kind of mental hardware altogether. They were not our primitive predecessors, they were a parallel experiment in what a human mind could be. This introduces a haunting theme in our story, the theme of lost roads. Evolution is not a straight highway leading to us. It is a dense forest with countless paths, most of which eventually fade back into the undergrowth. The Boskop people, with their immense cognitive capacity, represent one of those faded paths. Why did they disappear? The debate is fierce. Some experts argue they were simply absorbed into other populations, their distinctive trait diluted over generations. Others suggest they may have been a specialized group whose particular strengths were not favored as environments changed. Their story challenges a comforting assumption, the idea that our current form represents the pinnacle of a long, purposeful journey. Instead, it suggests our existence is just one possibility among many that once flourished. The silence left by the Boskop people echoes with questions about what was lost, what kinds of thought, art, or understanding vanished with them. It is a humbling reminder that the history of the human mind may be far richer and more tragic than we ever supposed, a prelude to finding evidence of other forgotten journeys written in bone. In the stark silence of the Atacama desert, a discovery emerged that was small in size but immense in its power to confuse. Within a deserted Chilean town, someone uncovered a tiny, linen-wrapped bundle. Inside was a skeleton so strange it seemed to defy all categories. It was merely 6 inches long, the size of a pen, yet its proportions were utterly alien. The head was severely misshapen and elongated, the face narrow and slanted. It had only 10 pairs of ribs, not the usual 12, and its bones showed the advanced maturation of a child perhaps 6 years old. This was no ordinary burial. The specimen, nicknamed Otter, quickly became an international sensation, with wild theories suggesting it was proof of something not from this world. The tiny frame seemed to hold a cosmic secret, but science, with its slow and methodical tools, sought a different kind of truth. A full decade after its discovery, advanced genetic analysis was finally performed. The results were definitive and deeply human. Otter was a girl, a female fetus, or a newborn who had not survived. Her DNA revealed not an extraterrestrial blueprint, but a heartbreakingly terrestrial one. She possessed a devastating array of severe genetic mutations, affecting at least 7 different genes crucial for skeletal development. These mutations explained her profound deformities and her tragically advanced bone aging, a condition that caused her tiny body to develop far too quickly. This case presents a different kind of challenge to our understanding of human biology. It does not point to a lost species or an unknown lineage. Instead, it illuminates the extreme outer boundaries of human genetic variation. It shows us the profound and often painful stories that are literally written into our bones. Otter's remains are not a mystery of origins, but a memorial to biological hardship. She reminds us that the human form is fragile and that our genetic code, while robust in its ability to create us, can also produce profound and difficult outcomes. Her story tempers our search for the exotic with a dose of solemn reality. Not every anomaly in the archaeological record is a sign of a new branch on the human tree. Some are deeply personal records of medical history, silent testimonies to the individual challenges faced long ago. This understanding of profound variation within our own species makes the next discovery all the more startling, for it comes from a time when our world was shared by other kinds of people entirely. The path of human history is not a lonely one. For most of our journey, we shared the world with other kinds of people, a reality made stunningly clear on the remote Indonesian island of Flores. Deep inside the Llangbua cave in 2003, archaeologists brushed away the earth to reveal bones that seemed to belong to a child. But as more of the skeleton was uncovered, a shocking truth emerged. This was a fully grown adult, yet it stood barely over 3 feet tall. Its skull was the size of a grapefruit, housing a brain smaller than that of a chimpanzee. This was not a diseased modern human. It was an entirely new species, officially named Homo floresiensis, but forever remembered by its affectionate nickname, the Hobbits. Their existence rewrites a chapter we thought we knew. These small-statured, small-brained people were not primitive simpletons. The cave floor around them was littered with sophisticated stone tools, finely crafted spear points, and evidence of cooperative hunting. They took down Komodo dragons and dwarf elephants called stegodon, turning their island home into a managed landscape. This presents the monumental challenge. How could a species with such a tiny brain exhibit such complex modern behavior? It forces us to confront a deep-seated bias, the assumption that brain size directly equals cognitive capability. The Hobbits prove that intelligence can be packaged differently, that neural efficiency and social structure can achieve what sheer volume alone cannot. Their very biology is a puzzle. Most scientists believe they are the product of a dramatic evolutionary process called island dwarfism. Imagine a group of early humans, perhaps Homo erectus, arriving on Flores over 1 million years ago. Isolated on an island with limited resources and no major predators, larger body size becomes a disadvantage. Over countless generations, natural selection favors smaller, more energy-efficient individuals. The result is a shrunken version of the original species, a unique adaptation to a unique world. But here is the truly mind-bending part. Current dating suggests the Hobbits survived until as recently as 50,000 years ago. This means that when our own ancestors, Homo sapiens, were spreading across Southeast Asia, building complex societies and creating art, another completely different type of human was living just a boat ride away. We were not alone. The Flores discovery utterly disrupts the clean, simple, out-of-Africa narrative that pictures a single triumphant species marching across the globe. Instead, it reveals the human family tree as a crowded, tangled bush, with multiple branches surviving and thriving deep into the recent past. The Hobbits are a powerful testament to evolution's creativity, showing how isolation can sculpt the human form into astonishing new shapes. Their sudden disappearance coincides roughly with our arrival on the island, a silent transition that raises profound and unanswered questions. Their story is a poignant reminder that we are the last survivors of a once diverse family, a sobering thought that makes the next discovery of another coexisting cousin all the more compelling. The story of the Hobbits reveals a world shared by many kinds of people, but what happens when an entire branch of our family tree is discovered not from a skeleton, but from a single fragment of a finger? Deep within the cold, silent chambers of Denisova Cave in the Altai Mountains of Siberia, archaeologists sifted through layers of time. In 2008, they found something that seemed insignificant, a tiny piece of a pinky finger bone from a young girl. It was so small and unremarkable that it would have been overlooked in any other context. Alongside it were a few teeth, equally cryptic. There was no dramatic skull, no complete skeleton to study. Just these scant physical traces, yet when scientists managed to extract ancient DNA from that sliver of bone, it triggered a genomic earthquake. The genetic code did not match Homo sapiens. It did not match Neanderthals, whose remains were also found in the cave. It represented an entirely new, previously unknown human lineage, which we now call the Denisovans. Here lies a monumental shift in our understanding. For over a century, paleoanthropology has been the science of morphology, of comparing the shapes of skulls and the curves of femurs to map our family tree. The Denisovans turned that approach on its head. We know them almost exclusively from their genetics. We have more of their genomes sequenced than we have of their actual bones. This is the challenge, a profound one, to our traditional biological toolkit. How do we write the history of a people who are physically almost invisible to us? The answer is written in us. That same genetic research revealed something even more astonishing. The Denisovans did not simply vanish. They interbred with our own ancestors as they migrated across ancient Asia. Today, significant portions of Denisovan DNA, up to 5% in some cases, live on in the genomes of modern populations in Melanesia, Aboriginal Australia, and parts of Southeast Asia. Their legacy is not in museums but in the living, breathing biological code of people today. This genetic gift was not merely a passive trace. Studies suggest that Denisovan genes contributed to modern human adaptations, such as the ability of Tibetan populations to thrive at high altitudes. A ghost lineage identified by a child's finger bone directly shaped the biology of millions of people alive now. This discovery forces a fundamental rethink. It tells us that the human story is not just written in stone and bone, but in the invisible molecular threads we inherited. It suggests that many of our ancestors may have walked the earth leaving only the faintest physical traces, their stories waiting to be read not in the shape of a skull, but in the sequence of our own DNA. It expands the stage of prehistory far beyond what the fossil record alone can show, hinting at a past filled with encounters and exchanges we are only beginning to comprehend. This realization that our identity is a mosaic of many forgotten peoples makes the next discovery, one of a truly lonely and isolated lineage, all the more poignant. The Denisovan legacy shows our past was woven from many threads, but what about a thread that seems to have spun its own story in total isolation? Far to the east, in the misty limestone caves of China's Yunnan province, a different kind of surprise was waiting. Here, researchers uncovered remains that were not ancient in a geological sense, but shockingly recent. These individuals, nicknamed the Red Deer Cave people after the animal bones found with them, lived a mere 14,500 to 11,500 years ago. This was not the deep past of the Neanderthals. This was a time when, according to textbooks, our own species, Homo sapiens, had long been the sole human masters of Asia. Yet the bones told a different, more complicated tale. The skeletons presented a bewildering mosaic of features that seemed to belong to different chapters of the human story. They had incredibly robust jaws, thick skull bones, and prominent brow ridges that echoed the anatomy of much earlier hominins like Homo erectus. Their faces were flat and broad with wide noses. In many ways they looked primitive, but they were not. They were contemporaries of what we would recognize as fully modern humans, people who were already developing agriculture just a few thousand years later. This creates a direct and fascinating challenge to the timeline of human dominance. How could such an apparently archaic form survive in a secluded corner of China, while the rest of the continent was being reshaped by people who looked just like us. The most compelling explanation is one of profound and lasting isolation. Imagine a population of early humans, perhaps a branch of the mysterious Denisovans or another ancient group, becoming trapped in the complex, mountainous river valleys of southwest China during the last ice age. As glaciers advanced and seas fell, creating land bridges and new routes for others, this group could have been cut off, their valley becoming a biological refuge. For tens of thousands of years, they evolved on their own path, their distinctive features becoming more pronounced with each generation, untouched by the genetic mixing happening elsewhere. They were an echo of an older world, persisting in a remote enclave while the human story changed dramatically beyond their mountains. Their discovery forces us to redraw the map of our recent past. It suggests that the ascent of Homo sapiens was not a clean, sweeping replacement of all who came before. Instead, it was a patchwork process. In some regions, like Europe, other kinds of people faded away relatively quickly after our arrival. In others, like these Chinese highlands, unique lineages may have held on for an astonishingly long time, creating a world where, just 12,000 years ago, a traveler might have encountered human communities that looked dramatically different from one another. The Red Deer Cave people are a testament to the power of isolation and the stubborn diversity of the human family. Their story ends without a clear finale. We do not yet know if they were absorbed into other populations or simply faded away, but their very existence stretches the boundaries of our imagination, preparing us for an even older and more fundamental challenge written in the very first chapters of our genus. But the story of Denisova Cave was not finished with a single finger bone. In the same frozen layers, scientists found another tiny relic, a fragment of a toe bone so small it could be overlooked entirely. It seemed like just another piece of the same puzzle, but when its DNA was sequenced, the results were not what anyone expected. This genetic code did not match the Denisovans. It did not match the Neanderthals who also lived there. It did not match us. This sliver of a person, nicknamed the X-Woman, represented something entirely new, a ghost lineage. Here we face one of the most profound challenges to our understanding of human biology, the challenge of absence. The X-Woman is a population we know existed only because of a whisper of molecules preserved in a cave floor. We have no skull to measure, no tools to associate with her people, no way to know what she looked like or how she lived. She is a statistical phantom in our genetic data, a definitive sign of a lost group whose physical remains have either vanished or are waiting, mislabeled, in a museum drawer somewhere. This changes the entire scale of the mystery. For over a century, we have built the human story from what we could hold in our hands, from bones and artifacts. The X-Woman tells us that this record is not just incomplete, it is profoundly fragmented. It suggests that the human family tree is not a neat diagram with a few clear branches. It is more like a dense, ancient forest where many paths were walked, but only a handful left any footprints deep enough to fossilize. How many other groups like hers lived, loved, and vanished without leaving a single complete skeleton for us to find? Her ghostly presence forces a humbling admission. Much of our evolutionary past may be permanently invisible to us, known only through these faint genetic echoes in the bones of others. It expands the stage of prehistory from a well-lit theater with a few key actors to a vast, shadowy landscape filled with movement we can only sense, not see. This realization that our history is populated by phantoms makes the next discovery all the more startling, for it presents not a ghost, but a tangible giant whose very bones defy the expected rules of human growth. Legends are not always born from nothing. Sometimes they are whispered memories of a world that has vanished. For the Paiute people of the Nevada region, the story of the CT car was a foundational part of their history, passed down through generations. These beings were described as formidable, red-haired giants who lived in the wetlands and waged conflict with the Paiute ancestors. For a long time, this was considered a powerful myth, a symbolic story about overcoming hardship. Then, in the early 20th century, something shifted. During guano mining operations inside Lovelock Cave, workers began to pull objects from the deep silt and then bones. Reports from the time, including newspaper accounts and letters, described the discovery of unusually large skeletons. Some were said to measure over 8 feet in length, and crucially, many were noted to still have tufts of reddish hair attached to the skulls. It was as if the legend had stepped directly out of the oral tradition and into the archaeological record. The official scientific response, however, has largely been one of skepticism. Many archaeologists argue the reports were exaggerated, that the skeletons were of tall but not gigantic individuals, and that the preservation of hair color can be unreliable after centuries in a cave. The original remains, if they ever existed in such a complete form, are mostly lost, leaving us with faded photographs and second-hand testimonies. This is where the challenge truly lies. The Lovelock case forces us to confront the messy intersection of folklore and physical science. On one side, we have a persistent, detailed cultural memory from the Paiute, a people with a deep, unbroken connection to that land. On the other, we have an incomplete and contested archaeological find that seems to echo that memory perfectly. Which narrative do we trust? Could this be evidence of a now lost population with distinctive traits, perhaps individuals with a genetic predisposition to great height and red hair who lived in the Great Basin thousands of years ago? Or does it point to something like pituitary gigantism, where a medical condition in a few individuals could have left a lasting, amplified impression on an entire community, transforming a rare biological event into a legendary race of giants? The significance is not necessarily in proving the literal existence of 8-foot-tall people, but in asking why this specific detail red-haired giants persisted so vividly. It suggests that long-term cultural memory can be a valid, if unconventional, historical source, potentially preserving truths about human biological diversity that the scant fossil record has missed. The Lovelock story is a haunting reminder that the past was populated not just by bones, but by stories, and sometimes those stories are the only maps we have to find the bones. It compels us to listen more carefully to the oldest tales, for they may hold clues to chapters of the human story we have not yet learned to read, leading us from the cave in Nevada to a different kind of vault, one holding a secret about the very fabric of our being. The challenge of classification becomes even more profound when we travel back to the very dawn of our genus. In the rolling hills of Dmanisi, Georgia, a volcanic layer sealed a moment in time 1.8 million years ago. Here, archaeologists uncovered not just fragments, but a series of 5 remarkably complete early human skulls. The last one found, known simply as Skull 5, became a quiet revolution. It belonged to an older male, his teeth worn down to the roots from a lifetime of use. His anatomy, however, stopped researchers in their tracks. He possessed a small, primitive brain case, one of the smallest ever recorded for an early human from this period. Yet his face was large and powerfully built, projecting forward in a way that seemed to belong to a different kind of creature entirely. This single individual embodied features that, if found scattered across different continents, would have been confidently placed into separate species. A small brain here, a massive jaw there, each trait had been used as a defining marker to name new branches on our family tree. But at Dmanisi, all these wildly varied features were found together in one place, in one population that clearly lived and died as a community. The implications are staggering. For decades, the early human fossil record from Africa and Asia looked like a bushy tree, with names like Homo habilis, Homo rudolfensis, and Homo ergaster designating what seemed to be distinct species. Skull 5 and the entire Dmanisi group challenges that entire framework. What if all that diversity does not represent separate species, but rather the natural variation within a single, highly adaptable, pioneering species? Think of the range of body types and facial features in a modern city today. Now, apply that concept to a small band of early humans spreading out of Africa for the first time, facing new climates, new foods, and new challenges. Their bodies would have shown immense plasticity. The Dmanisi fossils suggest that early Homo erectus, or a very similar group, might have been this incredibly variable founding population. Their small brains did not prevent them from crafting sophisticated tools, hunting large animals, and courageously expanding into new continents. This discovery does more than just rename fossils. It challenges the very practice of how we slice up the human past. It urges a profound simplification, a humility before the evidence. Perhaps we have been too eager to create a new name for every slightly different bone, inventing complexity where there was simply the beautiful, rugged variety of a resilient species finding its way in the world. The man from Dmanisi, with his small brain and strong face, asks us to see our earliest ancestors not as a collection of separate experiments, but as one bold, variable family taking its first steps into the unknown. The Dmanisi discovery reveals immense variety at our very beginnings, but what happens when a similar echo of the ancient past appears in a time and place where it simply should not be? In the dense forests of southwestern Nigeria, a rock shelter known as Eleru held a single, quiet answer. The skull found there is not old in the grand geological sense. It dates to a mere 13,000 years ago. By this point in history, according to the standard narrative, our own kind, Homo sapiens, with our high foreheads and subtle brow ridges, had been the sole human inhabitants of Africa for tens of thousands of years. Yet the Eleru individual tells a different, more primitive story. Its features are a startling throwback. The forehead slopes dramatically backward, and above the eyes sit pronounced, shelf-like brow ridges, an architecture reminiscent of hominins hundreds of thousands of years older. This was not a fossil from the deep past. This was someone living at the very end of the last ice age, a contemporary of artists and toolmakers we would instantly recognize as modern. This one skull creates a profound challenge to the idea of a clean, sweeping victory for our biological form. It suggests that the story within Africa itself, the very cradle of humankind, was not a simple one. For decades, the model suggested a single, triumphant origin event where modern humans emerged in East Africa and then replaced all older, archaic populations across the continent without mixture. Eleru stands as stubborn, bony proof that this replacement was neither clean nor total. In the isolated forests and river basins of West Africa, it seems populations with more archaic traits may have persisted, evolving in relative isolation for millennia. They were not replaced overnight. Instead, the continent likely hosted a mosaic of human diversity deep into the recent past, with different groups interacting, competing, and almost certainly interbreeding along shifting frontiers. This transforms Africa from a single starting line into a vast, dynamic arena where the human form was being shaped and reshaped in multiple regions at once. The significance is monumental. If archaic features could survive in West Africa until 13,000 years ago, then our own ancestry as a species is almost certainly a braided stream, woven from many different African lineages, some modern, some archaic, all contributing threads to the tapestry of who we are today. The Eleru skull is a powerful reminder that even in our homeland, we are the product of a complex, interwoven history, a truth that makes the next discovery, from a frozen island at the top of the world, all the more astonishing. The genetic whispers from Denisova Cave had more stories to tell, and one of them is profoundly intimate. From that same frozen ground came a tiny sliver of bone, so small it seemed insignificant. But when scientists managed to extract its ancient DNA, they read a life story more personal than any fossil could ever tell. This individual, a young girl who lived around 90,000 years ago, carried a genetic heritage that was a perfect 50-50 split. Her mother was a Neanderthal, her father was a Denisovan. She was a first-generation child of two different kinds of people. This single fact, written in molecules, delivers a quiet but devastating blow to an old, rigid way of thinking. For a long time, the classic definition of a species was a group that could only reproduce among themselves, creating fertile offspring. Under that strict rule, Neanderthals and Denisovans would have been considered completely separate species from us and from each other. The hybrid child from Denisova Cave shatters that simplicity. She is direct, undeniable evidence that these different groups were not isolated biological units. They met, they formed relationships, they had families whose children could thrive. This forces a monumental shift in perspective. We can no longer view these ancient people as entirely separate branches on a tree that never touched. Instead, we must see them as populations within a much broader, interconnected meta-species, all sharing a deep biological kinship and a capacity to blend. Suddenly, the Pleistocene world transforms in our imagination. It is no longer a lonely, wind-swept landscape dotted with isolated tribes of different human kinds, each keeping to their own. It becomes a dynamic, social world of encounters. Picture a river valley where a Neanderthal family group might trade with a Denisovan band, sharing tools and stories around a fire. In such moments, connections were made, alliances were formed. This genetic evidence suggests these interactions were not rare, violent clashes, but a regular, woven in part of life on the ancient steppe. The biology of every ancient individual, and by extension our own, becomes a tapestry. Some threads are Neanderthal, some are Denisovan, some are from other ghost lineages we have yet to name, all intricately blended into the fabric of who we are. This young girl's genome is a snapshot of that blending in real time, a living moment of connection preserved in the permafrost. Her story moves us from abstract categories of us and them to a deeply human truth, that curiosity and companionship have always been part of our journey, a theme that finds a stark and powerful contrast in the next discovery, where isolation tells a very different tale. A single skull can hold more than a brain. It can hold an entire era of uncertainty. This is the lesson of the Petrolona cave in northern Greece, where in 1960 a shepherd followed a curious path into a cavern and found a face staring back from the stone. Encased in a thick layer of calcite, as if the cave itself had tried to preserve it, was one of the most complete and perplexing skulls ever discovered in Europe. It was powerfully built, with a broad face and a truly monumental brow ridge, a solid shelf of bone over the eyes that spoke of immense physical strength. Yet, cradled above this primitive architecture was a surprisingly rounded and capacious brain case, hinting at a mind more advanced than the heavy brows would suggest. At first glance, it seemed to be a classic example of Homo heidelbergensis, a species often considered the common ancestor of both Neanderthals in Europe and modern humans in Africa. But the moment scientists tried to pin a date on this individual, the clarity vanished. Initial studies of the cave layers and the skull's mineral coating suggested an age of around 200,000 years. Other methods, however, pointed to a far more ancient origin, potentially pushing it back to 700,000 years or even older. This isn't a minor discrepancy. This is a chasm of 500,000 years, a span of time that encompasses multiple ice ages and sees the entire landscape of human evolution change. The Petrolona skull refuses to sit neatly on our timeline, and in that refusal, it presents a fundamental challenge. How do we understand a fossil that could be from two completely different chapters of the human story? Its robust, archaic features would fit comfortably in an older world, a Europe first being settled by ancient pioneers. Its more modern braincase, however, would align it with later populations clearly on the road to becoming Neanderthals. It embodies the frustrating, beautiful reality of a transitional form. Evolution does not work in leaps and bounds, with one species instantly transforming into another overnight. It works in gradual shifts, in populations where some individuals carry more ancient traits and others show glimpses of what is to come. Petrolona is likely a snapshot of that messy, magnificent process, a single individual who carried the deep past in his jaw and the emerging future in his brow. He does not fit our clean categories because he lived in the blur between them. This skull forces paleoanthropologists to confront the limitations of their own systems. We have a powerful desire to label, to place each fossil in its proper box on the family tree. Specimens like Petrolona resist that. They are biological mosaics, reminding us that the history of life is written not in distinct types, but in flowing, interconnected populations. The ongoing debate about its age isn't just academic bickering. It is a vital struggle to locate this pivotal figure in the correct narrative. Was he an early arrival, a rugged ancestor setting the stage? Or was he a later resident, a reminder that ancient traits could persist in isolated pockets? Until we can answer that, the skull remains a ghost in the corridor of time, a silent guardian at the crossroads of our own unfolding story. The search for our origins often leads to a quiet valley in Ethiopia, where the earth yielded not just ancient bones, but a profound message about the human spirit. At a site called Huesos, researchers uncovered 3 remarkably preserved skulls, dated to around 160,000 years ago. Anatomically, they are us. Their high, rounded brain cases and flat faces are unmistakably, definitively modern human, among the oldest physical examples of our kind ever found. But it is what was done to these skulls after their owner's passing that transforms them from simple fossils into a cornerstone of our understanding. Each one bears the unmistakable, fine-cut marks of stone tools. This was not damage from predators or random erosion. This was deliberate, careful work performed on the remains by other human hands. The skulls had been meticulously defleshed, and one showed evidence of polishing, as if handled and curated over a long period. This discovery presents a challenge that transcends mere biology. Here we have individuals who represent the very dawn of our physical form, yet their remains were treated not as mere organic matter, but as something imbued with meaning. The Huesos skulls force us to accept that the emergence of the modern human body was inextricably linked to the simultaneous emergence of the modern human mind, capable of complex symbolic thought and ritual. This was not a biology that existed in a vacuum. It was a biology already wrapped in culture, already asking the big questions about life, death, and what lies beyond. The cut marks are not signs of hardship or conflict, but of practice and care. They suggest a ceremonial process, perhaps an early form of ancestor veneration or a rite of passage for the living. The skulls may have been kept, displayed, or used in rituals that connected the community to those who came before. This intertwining of the biological and the symbolic is revolutionary. It tells us that by the time we looked like modern humans, we were already thinking like modern humans, already creating a world of meaning around us. The Huesos individuals are not just biological specimens, they are cultural artifacts. Their story beautifully blurs that artificial line we often draw between the physical self and the symbolic self. They show us that mind and body did not evolve on separate tracks, but advanced together, each shaping the other in a dance of increasing complexity. To be human from the very beginning was to be both a creature of bone and a creature of thought, honoring the fragile vessel that carries the spark of consciousness. The two skulls show a mind awakening to meaning, but what about a face that seems to belong to two different futures at once? In 1921, miners working at a site called Broken Hill in what is now Zambia blasted into a cave and uncovered a single, stunningly complete skull. It was instantly arresting, with a face of immense, rugged power. A heavy, bar-like brow ridge shadowed the eyes, and the overall structure was long and low, echoing a much more ancient human form. This was not a modern face. Scientists, believing they had found a unique and primitive ancestor exclusive to Africa, gave it a distinct name, Homo rhodesiensis. For decades, it stood as its own branch on the family tree, but time and better dating methods would reveal a far more interesting story. The Kabwe skull, as it is now known, is not from the deep past. It lived around 300,000 years ago, a pivotal moment when the human story in Africa was at a creative crossroads. Its true challenge lies in its impossible combination of features. While its brow and face shout antiquity, the brain case tucked behind that formidable visor is surprisingly large and rounded, hinting at cognitive advances. It is a mosaic, a living blend of the old and the new. This single individual disrupts the clean, linear model where one species neatly transforms into another. Instead, Kabwe acts as a crucial biological node, a central point in a vast, interconnected network. It shows that the traits we later see separated, the robust features that would come to define Neanderthals in Europe, and the more graceful architecture that would characterize modern humans in Africa, were once mixed together in widespread populations across the continent. The Kabwe person was not necessarily a direct ancestor to everyone, but rather a representative of the diverse ancestral stock from which both later lineages would draw. Think of a great, ancient river delta with countless channels intertwining before some flow westward and others eastward. The Kabwe skull is a snapshot of that delta, a reminder that before there were clear branches, there was a tangled, fertile root system. Its existence forces us to abandon the idea of a single missing link and embrace a messier, richer reality where evolution worked on a whole suite of features in different combinations across a continent. This rugged face from Zambia is not an endpoint, but a portrait of potential, a single frame from a film of transformation that was playing out simultaneously from Africa to Europe and beyond. A skeleton can be a roadmap of a life, and one particular set of bones charts a journey across an ancient, sun-scorched landscape. In the harsh, beautiful terrain near Lake Turkana in Kenya, researchers unearthed a treasure not of gold, but of bone, a nearly complete skeleton of a young male from 1.5 million years ago. Known as the Turkana Boy, he is a time capsule from the species Homo erectus, and he forces us to completely redraw our mental picture of early humanity. Forget the stooped, ape-like caricature shuffling along the ground. This youth stood tall and slender, his limbs long and linear, his body built for efficiency in motion. From the neck down, his proportions were strikingly modern, an anatomy engineered not for life in the trees, but for a life of relentless travel across open savannas. His very form is a statement of adaptation. That tall, lean build was a biological solution for endurance, for walking, and crucially, for running long distances under the African sun. This was a body capable of persistence hunting, of tracking prey over miles until the animal succumbed to heat exhaustion, a strategy that requires not just speed, but phenomenal stamina and the ability to shed heat effectively. The Turkana Boy Skeleton tells us that this revolutionary way of life, of using our bodies as engines of endurance, was already perfected an astonishingly long time ago. This is where the profound challenge to our story emerges. For decades, a common narrative placed the development of our large, complex brains as the pivotal trigger for all other human advancements. We imagined intelligence leading the way, inventing tools and strategies that then shaped our bodies. The Turkana Boy inverts that sequence. His body was already modern, already a masterpiece of terrestrial adaptation, a full million years before the dramatic brain expansion that would characterize later Homo sapiens. The brain housed in his skull was only about 2/3 the size of our own. This means the fundamental human transition to a life of relentless mobility, of exploring ever-expanding horizons, came first. The legs, the lungs, the sweat glands, these were the pioneering technologies. The mind, in evolutionary terms, played catch-up. This skeleton beautifully decouples two major threads of our evolution. It shows that the physical vessel for humanity, the platform from which we would eventually conquer every continent, was built and tested long before the onboard computer received its most powerful upgrades. The Turkana Boy does not represent a primitive step. He represents a completed prototype, a proof of concept for the human body as a machine of exploration. His silent bones ask a humbling question. What good is a brilliant, creative mind without a body capable of carrying it to the ends of the earth? Deep within the Atacama mountains of Spain lies a cavern known as Cima de los Huesos, the Pit of Bones. To reach it, you must descend a narrow vertical shaft, a treacherous climb down into profound darkness. At the bottom, the floor is not made of stone, but of a densely packed layer of ancient human bone. This is not a random scattering. Over 6,500 fossil fragments have been recovered here, representing at least 28 individuals of the species Homo heidelbergensis, all dating back 430,000 years. The sheer scale of the assemblage is the first monumental challenge it presents. This is not a single grave or a scattering of remains from a tragedy. This is a curated collection of an entire community, accumulated over what appears to be a considerable span of time. How did they all get there? The geology of the pit offers a stark answer. The shaft is a natural chimney, a nearly impossible place to reach by accident. There is no evidence of habitation, no tools or hearths at the bottom. The only logical conclusion is that these bodies were carried, one by one, and deliberately placed into this deep, remote chamber by other members of their group. This act transforms the Pit of Bones from a paleontological site into a profound archaeological statement. It suggests a practice, a repeated behavior surrounding the end of life that goes far beyond the biological. We are witnessing what may be the earliest evidence of a funerary rite in the entire human lineage, a behavior we once believed was the exclusive hallmark of our own species, Homo sapiens. The biological details of the bones add another layer of significance. These heidelbergensis individuals show a clear mosaic of features. They possess robust, projecting faces and certain dental traits that are unmistakably ancestral to the Neanderthals who would dominate Europe hundreds of thousands of years later. Yet they also retain more primitive characteristics. They are a snapshot of a population in transition, biologically caught between an ancient past and a specific future. But it is their collective fate, not just their anatomy, that truly challenges our understanding. The deliberate placement of these remains in a difficult-to-access pit implies a shared concept, a communal response to loss. It hints at a social world far more complex than we credited to these pre-Neanderthal humans. Did they possess a sense of an afterlife, a belief that required a special resting place? Or was it a simpler, yet no less profound, act of respect, of separating the living from those who had passed in a designated space? The Pit of Bones forces a humbling realization. The deep roots of what we consider uniquely human social behavior, care for the dead, ritual, a sense of community that transcends the immediate moment, may be hundreds of thousands of years older than we ever supposed. It suggests that the capacity for such thought is not a biological switch that flipped only with our arrival, but a potential that was slowly, patiently cultivated over vast stretches of time by other kinds of people. This silent congregation in the dark asks us to listen more carefully to the past, to hear in their actions the early, echoing footsteps of a mind beginning to grapple with the greatest mystery of all. But the dawn of our form has a specific address along the banks of Ethiopia's Omo River. Here, in the Kibish geological formation, lie the remains known simply as Omo I and Omo II. These are not strange or distorted bones, and that is precisely what makes them so revolutionary. Dated to around 195,000 years ago, they represent some of the oldest physical evidence of people who look, in every anatomical sense, just like us. Their high foreheads, rounded skulls, and delicate facial structures are unmistakably modern human. This should be a triumphant discovery, the final piece of the puzzle showing our emergence. Instead, it introduces a profound and haunting disconnect. These individuals, with our bodies and our brains, lived a staggering 150,000 years before the so-called creative explosion, that period around 50,000 years ago when archaeologists see an undeniable surge in symbolic art, complex tools, and ritual behavior across the globe. The Omo fossils present a quiet but monumental challenge to a comforting narrative. They force us to separate two ideas we have always assumed evolved together: biological modernity and behavioral modernity. For over 100 millennia, it seems, people who were physically identical to us walked the earth, yet the full tapestry of what we consider human culture, cave paintings, carved figurines, sophisticated adornment, remains absent from the archaeological record for most of that time. What does this mean? It suggests our biological potential, the hardware of the modern human mind, was fully assembled long before the software of our most iconic behaviors began to run. This period becomes a haunting era of latent capability. Imagine possessing a concert grand piano for a century before anyone discovered how to play a symphony. The instrument was there, the potential was inherent, but the specific cultural and social conditions needed to unlock its full range of expression had not yet coalesced. Perhaps it required a tipping point in population density, a new level of social networking that allowed ideas to spread and compound. Maybe it was a slow, internal evolution of cognitive wiring, a neurological fine-tuning that finally allowed abstract thought to be consistently externalized. Or could it be that the evidence of earlier creativity is simply lost, made of perishable materials like wood or hide that vanished long ago? The Omo remains do not give us those answers. Instead, they give us a profound mystery. They tell us that the story of becoming human was not a single event but a long, slow dawn. The body arrived first, a vessel waiting for its voyage. The journey of the mind, it seems, took a much more winding and patient path. This realization reframes our entire past not as a sudden birth, but as a prolonged gestation, a deep history where we were physically present, yet still discovering what we were truly capable of becoming. Even the way we walk has a history. While the red deer cave skulls presented a face from a lost time, it was a single thigh bone from the same site that revealed how these people truly moved through their world. This femur, sturdy and thick-walled, tells a story not of disease or deformity, but of a different kind of engineering. When researchers analyzed its shape and internal structure, they found a blueprint for a gait unlike our own. The angles of the hip joint, the way muscle attachments were reinforced, all pointed toward a unique pattern of locomotion. This individual did not stride with the familiar, efficient role of a modern human covering long, open distances. Their movement was likely more stable, perhaps with a wider stance or a subtly different transfer of weight with each step. This is a challenge on a deeply fundamental, biomechanical level. We often think of walking on two legs, bipedalism, as the great finished invention of early human evolution, a solved problem that all subsequent people inherited. The Maludong femur proves that assumption false. It shows that even as recently as 14,000 years ago, natural selection was still actively tinkering with the human body's core machinery, tailoring it to specific environmental pressures. In the steep, forested river valleys of southwest China, the optimal way to move may have required more lateral stability for climbing or navigating uneven terrain than the efficient, straight-8 gait that served others on open plains. This single bone transforms our understanding of human adaptation. It reveals that there is no single, perfect human form for walking. Instead, our locomotion is a flexible toolkit, and evolution can customize that toolkit for local conditions, creating regional variations in how the human body is built and used. The Red Deer Cave people were not just archaic in appearance, they were biomechanically distinct, a population sculpted by their secluded landscape into walking a path that was literally their own. Their legacy, written in the architecture of a femur, is a powerful reminder that our globalized modern form is just one configuration, and that the human story is filled with other, now silenced ways of being perfectly adapted to a forgotten home. The story of our ancestry is written not only in stone, but in the silent molecules within the bone itself. In the frozen silt along the Irtysh River in Siberia, a single thigh bone rested for 45,000 years. Known as Ustitium Man, this fragment would become a genetic time capsule of extraordinary precision. When scientists sequenced its genome, they were not just reading the blueprint of one individual, they were recovering a lost chapter from the very moment our story intersected with another. The DNA revealed something startling. This man, one of the earliest modern humans known to have lived in Siberia, carried segments of Neanderthal ancestry that were exceptionally long and unbroken. This detail is the key to everything. When two populations mix, the segments of DNA they exchange are like large, distinct blocks in a mosaic. Over successive generations, those blocks get broken into smaller and smaller pieces as chromosomes are shuffled with each new child. The exceptionally long Neanderthal segments in Ustitium's genome mean that he lived only a handful of generations, perhaps just 200 or 300 years, after his ancestors had interbred with Neanderthals. For the first time, we could place a nearly precise timestamp on that pivotal encounter. It happened roughly between 50,000 and 60,000 years ago, a fleeting window of connection in the deep past. This genetic snapshot challenges a static, linear view of ancestry. It shows that our family tree is not a series of clean forks, but a dynamic, flowing river where tributaries merge and separate. Biologically, Ustitium Man carried even more Neanderthal DNA than the average person of European or Asian descent does today. His genome proves that the initial genetic gift from our ancient cousins was richer and more substantial. Over the subsequent millennia, as his descendants continued to mix within larger modern human populations, those long, distinctive segments were gradually broken down and diluted. Some Neanderthal genes were likely weeded out by natural selection if they were disadvantageous, while others, like those aiding immune function, were kept and are still with us. This single femur transforms a vague historical possibility into a dated, personal event. We are no longer talking about abstract interbreeding somewhere in deep time. We are looking at the genetic echo of a real community, where Neanderthals and modern humans were not just neighbors but family. Ustitium Man is a witness to that intimate moment of blending, a reminder that our biological identity has always been a work in progress, shaped by encounters we are only now beginning to understand. High on the slopes of a dormant Andean volcano, time itself seems to freeze. Here, at an altitude where the air is painfully thin, a discovery was made that transcends the usual categories of bone and artifact. In 1999, near the summit of Mount Llullaillaco, archaeologists uncovered 3 Inca children, a girl and 2 younger companions, who had been placed in a ceremonial platform over 500 years ago. They were not skeletons, they were mummies of such phenomenal preservation that they seemed merely asleep, their skin intact, their hair braided, their faces peaceful. This is a different kind of challenge to our understanding, one that moves beyond the architecture of bone to the living, cellular machinery of a human body suspended in its final moments. The Llullaillaco maiden and the children offer a biological snapshot of unparalleled intimacy. Scans revealed their internal organs were perfectly preserved. Scientists could analyze the contents of their stomachs, trace the remnants of their last meals, and even detect traces of alcohol and coca leaves in their systems, substances likely used in the ceremonial rites leading to their passing. Their very blood, frozen in time, still flows within preserved capillaries. This level of preservation provides a cellular-level window into human physiology under the most extreme conditions imaginable, both environmental and emotional. These individuals were part of a profound Inca practice known as Capacocha, a ritual sacrifice believed to appease deities and ensure cosmic balance, often involving children of great beauty and health. The challenge here is not to our evolutionary tree, but to our comprehension of the human body as an integrated system pushed to its absolute limits. Researchers studying hair samples from the maiden could read a timeline of stress in her final year. The data showed a significant shift in diet and an increase in cortisol, a stress hormone, in the months before her journey to the summit. This is not a story written in stone tools or skull shapes, but in biochemistry. It reveals how cultural meaning and biological reality became intertwined on that mountainside. Their bodies also tell a story of astonishing adaptation. These children, likely from lower altitudes, were led on a long pilgrimage upward, their physiology gradually, or perhaps abruptly, forced to contend with the brutal hypoxia of altitudes over 22,000 feet. Their preserved tissues allow scientists to study how the human body responds to such extreme altitude, offering clues about ancient Andean resilience that are literally written into their cells. The Llullaillaco finds challenge us to expand our view of human biology. It is not merely a collection of skeletal traits to be classified. It is a dynamic, full-spectrum system of metabolism, stress response, and adaptation, forever captured at a point of profound cultural significance. These children remind us that the human story is recorded not just in what we left behind, but in the very fabric of our flesh, a final, poignant testament to lives lived at the intersection of belief, duty, and the thin, cold air at the roof of the world. These 20 silent witnesses do not tell separate stories. Together, they weave a single, undeniable truth about our past. The classic image of human evolution as a straight ladder, each rung neatly leading to the next and culminating in us, lies shattered. In its place stands a far more vibrant and chaotic reality, a tangled, ancient bush with countless branches reaching in every direction. For millennia, different kinds of people walked the earth at the same time. They met in river valleys and on mountain passes. They shared landscapes, exchanged technologies, and in many profound instances became family. Their world was not a lonely march toward a single destiny, but a dynamic, crowded ecosystem of human diversity. Some branches, like the Neanderthals and Denisovans, flourished for hundreds of thousands of years. Others, like the Hobbits of Flores or the Red Deer Cave people, clung to existence in isolated pockets. And still others, like the ghost lineage of the ex-woman, are known only by a whisper in our genes, their stories almost entirely lost to time. This is the collective challenge these bones present to our understanding of biology itself. They scream that the natural variation within the human family, both in the deep past and echoing into the present, is vastly greater than our neat scientific categories were designed to hold. A single skull can possess a brain case that hints at modernity while its jaw shouts antiquity, defying easy classification. A tiny finger bone can rewrite the entire map of prehistory without a single accompanying artifact. This evidence forces a necessary and beautiful collapse of disciplinary walls. The story of us can no longer be told by archaeology alone, with its careful study of tools and hearths. It cannot be told by paleoanthropology alone, with its meticulous measurements of brow ridges and femur angles. It certainly cannot be told by genetics alone, with its maps of ancestral mixing. The true narrative only emerges when these fields speak to one another, when the stone tool is considered alongside the DNA extracted from the soil nearby, when the shape of a skull is read in concert with the ancient pollen found in its burial layer. This interdisciplinary dialogue is where the magic happens, transforming scattered facts into a living history. Ultimately, what these remains teach us above all is a profound humility. For every definitive answer a fossil provides, it seems to raise three new, more intricate questions. The discovery of one ancient skeleton does not close a chapter, it opens a doorway to a dozen unexplored rooms. They remind us that the search for origins is not a puzzle to be solved, but a conversation to be continued, a mystery that deepens the more we learn. These bones, in all their strange and silent majesty, continually ask us to reconsider the most fundamental question of all. In a family tree so wildly diverse, filled with cousins who looked nothing like us yet thought, loved, and grieved in their own ways, what does it truly mean to be human? From the elongated skulls of Paracas to the hybrid child of Denisova, each discovery we have explored is a single, vital piece in a grand and deeply incomplete puzzle. These ancient remains do not whisper from the margins of history. They stand at the very center, challenging the foundations of what we think we know about human biology. They reveal a past not of a lonely, linear march, but of a world astonishingly rich with diversity, a tapestry woven from countless threads of adaptation and mystery. Every strange skull and unexpected skeleton asks us to reconsider the story we tell about ourselves. They push us to see our family tree not as a clean, ascending line, but as a wild, ancient forest where many paths were walked, most of which eventually faded back into the shadows. This is the profound legacy of these 20 witnesses. They transform history from a settled record into an ongoing, thrilling investigation, a conversation with the past that is constantly being rewritten with each new fragment unearthed from the earth. If this journey into the deepest corridors of our shared story has sparked your curiosity, there are countless more historical mysteries waiting to be explored. Consider subscribing to join us as we continue to uncover the secrets hidden in time. Now, we would love to hear from you. Of all the challenges these bones present, which one do you find the most compelling? Is it the potential of the Boskop mind, the silent ritual of the pit of bones, or the intimate encounter preserved in the genes of a child from Denisova? Share your thoughts in the comments below. Let us keep unraveling the magnificent, mysterious story of us together.